Welcome to my channel. I'm Zhang Jingxu. Let's look at the problem 42 in chapter 28. Chapter 28 is about the source of magnetic field density. So there you can see we need to determine the magnetic field density at position P for this loop, square loop with current in the clockwise, right? And then the problem still give us a hint to consider the result in problem 41. So in problem 41, we can see it's a wire. The length is D, located at negative x direction. And it's a position P. We can consider its magnetic field density in this way, right? In this direction. So from this one, we can see we can cut this square length in 4 parts, right? So part 1, part 2, part 3, part 4. If we just consider the length part 4, just the side length for part 4, since it's a little bit different from the model we talk about, right? So in the model, we can see the P is just above one end of the wire. So we can extend this part 4 to the length 2D, right? So we get this part, and to cancel it, we consider the side 5. The side 5 just flows in opposite directions to cancel the current we just added, right? Okay, now the magnetic field at P should be the magnetic field B1, B2, B3, B4 plus B5, right? Yes, so first one we look at B1. For B1, of course, magnetic field is 0 because P is just located at axis of wire 1, right? Now look at the side 2. So part 2, we can say first we determine its magnetic field density. If you use the right-hand rule, you can say this is flows in, right? Flows in. So at the position P, the magnetic field density flows in. But there we consider the flows out as positive. So flows in negative. So first one we determine its direction negative. And then for this magnitude, we can see the length for the wire D and the distance from wire to the position P become 2D, right? So replace Y as 2D, you get it there. Similarly, we look at the wire 3. For wire 3, we need to determine its direction. Of course, this is the opposite direction with side 2, right? So this one is positive K direction. You can use the right-hand rule. And then for this one, you can see the length is D, the distance from the part 3 to position P is D. So now we replace Y as D, get answer there. The part 4, we can see, for part 4, you can see the side length becomes 2D, right? The distance is D. So there, replace the D as 2D and the Y as D. Agree? The next one, we need to determine the magnitude directions. If you use the right-hand rule, you will find in this case it flows in. So this is the negative K direction, and then we get it there. For part 5, so for part 5, we can see the direction is flows out because the current flows to the right? Flows out, and then the distance is D. So we replace Y as D and the length is D, and then we get it there. Now we add these 4 vectors together, and we find it for the B3 plus B5, right? B3 plus B5, you just this 2 magnitude is the same, so you just times 2 there, right? And then plus the B2, B4, you get it there. Both of them are negative side, right? And then you just organize it and then simplify it, you get answer there. Thank you.